Hey everyone, welcome to this new series. In this playlist, I will be talking about the foundational and strategic approaches to scale generative AI. The idea behind this video is simple to help the business owners have better conversations with their clients about the pros and cons of different GenAI approaches, to help the technical teams make the right implementation decisions, and to support anyone who just wants to understand the generative AI in a clearer way. In this first video, I will cover two things. First, an introduction to what scaling generative AI really means and why it matters now. And the second, a quick overview of a framework I have been using to break down this topic. And once the base is set, I will go deeper into each area in future videos. So let's start with the basics. What do I mean by scaling generative AI? uh, it's not just about making models bigger. It's about taking something that might work well in a lab or prototype and getting it work smoothly and reliably in the real world. That means the building models that can handle complex tasks like jumping from GPT-3 or 3.5 to 4.1. And it also means making these models available to a lot of people across different use cases, regions, and platforms. On top of that, we need to make sure the performance doesn't break down as more users and data types are added. I have to manage cost, infrastructure, latency, and compliance, all while keeping the system efficient and useful. So again, it's not just about the size; it's about building something that actually scales and works in production. Now, why does it matter now? Because Genie is moving fast. What started as demos or fun tools is now being used to power real products like coding assistants, creative apps, chatbots, and even search tools. We are seeing it across the industries like finance, healthcare, education, even manufacturing. But as adoption grows, there are some tough trade-offs. I have to balance the performance and cost. I need to keep things fast and also safe and accurate, and that gets harder at scale. There are also big trends shaping how this plays out. Multimodal AI is becoming more common. Models that understand text, images, audio, and even video. And agent-based systems are starting to show real promise where models can reason and act step by step. And also smaller specialized models are getting attention too, like Midpalm in healthcare and FinGPT in finance. Then there's the move forward age deployment and the growing push to reduce energy use and make AI more sustainable. So really, generative AI is no longer just an experiment. It's becoming part of the core digital infrastructure, and how we scale it really matters. And of course, the opportunity comes with complexity. As we attempt to scale the systems, we run into a range of challenges that span from hardware layer to organizational workflows. Let's break them down. So first, the infrastructure and compute constraints. Training and running large models demands massive computational power, which translates to high cost and significant energy use. And models with long context windows or multimodal capabilities push the memories to its limits, and so many different hardware platforms like GPU, TPU, custom chips, managing compatibility is very difficult. Then the second, we have model design and behavior. As models grow larger, we often expect better performance, but that's not always the case. In fact, bigger models can sometimes behave unpredictably. We face trade-offs between size, latency, and quality. So sparse architecture and mixture of expert models introduce new engineering complexity. And as the model scales, so does the risk of hallucination, instability, and lack of control. Then third, we have scalability and integration complexity. So real-time use cases demand fast inference, but latency often becomes a bottleneck. Deploying models across clouds, devices, and edge environments isn't straightforward. So running generative AI at scale also means high serving cost and difficult integration with existing enterprise systems. And then finally, we have this monitoring, evaluation, and risk management. We still lack robust evaluation frameworks for generative AI models, especially at scale. Safety issues, bias, and fairness become harder to detect and mitigate. Most teams struggle with observability, tracking usage, and gaining insights. On top of that, enterprise like face rising pressure to meet compliance, retention, auditability standards. So overall, scaling generative AI is not just a technical effort; it's a system level challenge, and that touches the infrastructure, software, user experience, and governance. So the framework I propose has four core dimensions, each addressing the different layer of scaling generative AI. And before we jump into that, we also need to understand why we need to have a structured framework. Because to approach scaling, not as of a one-off engineering task, but as a coordinated and strategic process. And ad hoc solutions often lead to duplication, inefficiencies, or systems that work in isolation but fail at scale. So a framework gives us a way to connect efforts, prioritize decisions, and scale responsibly. So the first one is computational scaling. The it looks like we optimize resources during training and inference. This includes like parallelization, quantization, hardware choices, and efficient fine tuning techniques. And then we have architectural scaling that focuses on how models are designed. That includes sparsity, modularity, and architectural patterns like picture of experts or compressed models that maintain performance while reducing the overhead. And then we have deployment scaling. This addresses how models are served and integrated. This covers the real-time inferences, deployment, orchestration, caching, and API design to scalable applications. Um, then we have the operational scaling. So it's about keeping things running smoothly over time. It involves monitoring evaluation pipelines, governance, and ability to adapt and roll back to models safely. So together, these dimensions offer a holistic lens, helping us assess and manage scaling in a way that's aligned with both business goals and technical realities. Next, we will be understanding computational scaling in a much deeper way. Thank you so much.